So our total potential we need to find, that's just going to be the potential between our different pairs of particles in there. So it would be like the potential between particle 1 and particle 2 plus the potential between particle 1 and particle 3 plus dot 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 dot, all the way to the potential between n and 1 plus 2 and 3 plus dot dot dot, all the way u n minus 1 and n, right? So that would just give us the total potential between like interacting pairs of particles there, and then we could just say that's the summation of u, I, j, where I and j are just indices for the different particles that we have interacting. So then our z, c eventually becomes 1 over v to the n integral of d3r1 dot 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 d3rn, all then, so like these were up in the exponents, remember, so it would be like e to the negative bu 1, 2, and then plus another one. So when you add, or like when you multiply exponents, you're actually adding the exponents themselves. So this just becomes the infinite product of e to the minus beta u I j. Now this is not exactly easy to work with, so we're going to change it up a little bit. We can actually say that because u I j is much less than kt, the Boltzmann factor here is like pretty close to 1. So this whole thing, so we're just going to say e to the u I j is kind of equal to 1. And then we're dealing with a lot of other factors here, so we're going to say that there's like this like distortion, you can kind of think of it as, so they're called Meyer F functions, ij, so that's just telling you like how far away or like how much you're differentiating away from the actual idealness of this gas. So if it were an ideal gas, this would be 0 and you just end up with 1, which is what you would want to do, but instead we have these factors here, and this part right here is the same as, like I said, it was just that part that we're varying away from 1. So if you took the infinite product of these, you're going to get 1 plus fij, there's like an infinite product of these, which is the same thing as saying 1 plus fij times 1 plus fkl, and there's a lot of these factors. So when you multiply all these out, you're going to get a 1 plus, and then you're going to get a lot of factors that are just one term, like 1 fj, because you have 1 times 1, and then you have this fij times 1 times 1 times 1 times 1 times 1 times 1. So you're going to get the infinite sum of just fij, and then you're going to have another infinite sum of things with 2 factors in them, so then you get fij, fkl, plus dot dot dot, and then you just keeps going on. So then we're actually going to plug this back into here, and let's see if we can make something. This dc is equal to 1 over v n integral dq1 plus d3r times all of this fun stuff, 1 plus summation of fij plus summation of fkl times fij plus dot dot dot. And this other stuff's getting in my way, so I'm going to erase this. Right? And then here we have this one becomes pretty simple, and then these other ones are like you can almost think of them as like perturbations away from your ideal gas.